So our next big O is O of 1. And to explain this, I'm going to build out a function that we're going to call add items. And all this is going to do is return n plus n. And this is our first big O, where the number of operations does not change as n becomes larger. So in this situation, if n was 1, we would have one operation, which is the addition. But if n went all the way to 1,000,000, we would still have one operation, which is the addition. And that is O of 1. But what if instead of having n plus n, we had n plus n plus n? Well, now this would be two operations, and you could call that O of 2. But as you may have guessed, we're going to simplify this, and we're still going to call this O of 1. So now let's take a look at O of 1 on the graph. So O of 1 is just that purple line across the bottom. It is the most efficient big O because as n becomes larger, the number of operations does not become larger. So anytime that you can do something with O of 1 time complexity, that is going to be very efficient. And that is our overview of O of 1.